W11 can do is doing the keyboard input without echo. All right. So what does this means? All right. So it means that without echo means that the information is not displayed on the screen. Okay. So when we type from the keyboard, let's say we type a letter D. Okay. But that letter D is not shown on screen. Instead, it is stored in the register. Okay. So to do that, we need to set. Okay. We need to set A hash to be 07. Right. Then we type interrupt 21. Then we will see whenever we key in an input from our keyboard, there it is not shown on the screen. It is stored on the register. Okay, and next thing that we can also do, okay, with the interrupt 21 is we can use the label. Okay, so the label is a directive, okay, which can be used in the data segment to assign multiple names to the data, right? So we can, okay, so we can use this, all right? So we have name, okay, and label. So what is our label? And then the attributes, okay? The attributes, let's say it is byte, okay? And this is the name of the label that we want to label. Okay? So we used to assign the same offset address to two names, okay? So the attributes can be either byte, okay? So this attribute can be the byte, word, double word, okay? F word, Q word, okay? And T byte, okay? So D, okay, four, okay, double, four, quad word, okay, so T, so we can use whatever it is in this attribute. Okay, for example, we have a label, we label a person, all right? Let's say Joe, okay, and label, okay, and then this Joe, actually the offset address assigned to this Joe is the same offset address for Tom over here, okay? So then we just put the label over there, okay? So one more thing about the label, it does not occupy any memory space. Okay, for example here, we have a label directive, okay, where we want to define the buffer area for the string keyboard input. So for example here, our label is data underscore buffer, okay. So it is related to the buff area over here. Okay, in the code segment, all right, so we can access the data, okay, using the following instruction, okay. For example, okay, so we set AH as 0A, where we want to load the string into the buffer, okay, and then we type offset data buff, right? So this is the label, okay, and put that into the DH, and then we invoke the interrupt, okay, int21, okay, and then the buff count, okay, so we want to count actually how many buffers that we already have. So we put that, actually it depends on the length of the string, okay. Let's say we type a string, let's say we put a name, let's say J-O-E, all right, J-O-E, so it's Joe, so the string is Joe. So we want to know how long is the string, that is 3 byte, for example, okay. So that's a buff count, so we put that into the CL register, okay. And then after that we call that, okay, we call that this, okay, the main buffer, all right, which is in the database, which is the buff area, okay, and then put that as offset into the SI, okay, SI register, which is the segment register, okay. All right, so that's it about the interrupt 21, okay. So to review back, so we have okay, first we can set a set of ASCII data to the monitor where we set AH as 09, okay, and we change the DX, okay, which is offset data of the ASCII data. So that one thing, which is outputting a data string to the monitor. So that's one of application with the interrupt 21. Okay, and also second one is we can do to output a single character. Okay, so over here we put AH as 02, okay, and we change the DL. Okay, next we can put the single character with echo, okay, which is not shown on the monitor. Okay, so for this one we set AH as 01, okay, and then we can also input a data string from the keyboard where we set, okay, AH as 0 A, okay, and we change the DX. Okay, and then next we can also, okay, key in from the keyboard but without echo, meaning that we don't display that on the monitor, okay, where the command is we put where the instruction is we make AH equals to 07. Okay, and last one we use a label directive, okay, with the interrupt 21. Okay, so that's the application that we can use with the interrupt 21. Okay, and next thing is the last topic in this chapter is a macro. So what is a macro? A macro where we want to do a task that is repeated in many times. Okay, so it does not make sense for us to write the task, okay, every time, okay, in the code. So we don't need to rewrite it again and again, okay, just to assign the similar task. Okay, so these macros allow us to write the task once only, okay, and invoke it wherever is needed. Okay, so it also reduce our time to write the code and reduce the possibility of errors. So that's the two advantages of that. Okay, so this is how we can use macro. Okay, so macro is a directive. Okay, so this is how we can assign the macro. So we assign a name for that macro, and then this is the operand that we want to use with the macro. Okay. Okay, so and then in the end we have n m. So mean that we end the macro. Okay. So this is located within the body of the macro. Okay. And then the name here, all right, must be unique. That is not used by other type of assignment. Okay, assignment that we already use in the code. Okay. Okay, so over here, this all dummy 1, dummy 2, and dummy n are the names of parameter or registers that are mentioned in the body of the macro. Okay, so the macro can be invoked. Okay, so like interrupt can be invoked by its name. Okay, so we just we write the name and then it will call the function of macro, and appropriate values substituted for these dummy parameters. Okay, for example over here, okay, so we use a macro to display a string of data using the widely used function of 09, okay, interrupt 21. Okay, so meaning that we want to repeatedly use the function 09 of the interrupt 21, so we use the macro. Okay, for example here, the name of macro is a string. Okay, and then what is the operand that is related is the data 1. Okay, so over here we already define first how data 1 is going to be accessed. Okay, so data 1 we put that into the dx, and then 09 we put into the ah. Okay, and then we invoke this interrupt. Okay, on the other usage, all right, the macro can also be invoked by its name with the user's actual data. Okay, for example, we have here string, okay, message 1. Okay, so message 1 is already defined here on the top. So let's say we want to call type. Okay, we want to repeatedly ask, okay, what is your name? What is your name? And what is your name? So we just string. So rather than typing this string, which is long, okay, we just type the message 1. Okay, so that is the function of the string. Okay, so over here, actually, this is after we put this one. Okay, so do you still remember what does AH09 do? Is we want to display the message that we type from the keyboard. Okay, as it is in here. Okay, like this one. Okay, so we want to show, okay, we want to show the string what it display here. All right, so we want to repeatedly do that task. Okay, so for example, so like this one, you want to keep asking what is your name, what is your name, and what is your name. Okay, so that's why we use the macro over there. Okay, so the assembler, so which is once we assemble this, expands the micro by providing this code in the .lst file. Okay, so this one, if you use the MASM program, okay, so it will show this one. Okay, so if you see that 111, so this is indicates that the code is from the macro. Okay, but this is for the latest one. But for the previous one, for the previous one, so this actually showing you the plus sign. Okay, shows you the plus sign. Okay, we can also put comments in the macro. Okay, whether it is listable or non-listable. Okay, so comments preceded by one semicolon, okay, will show up in the .lst file, okay, when the program is assembled. For example, this one, so it will show you the comment over here, okay, in this .lst file. Okay, so for another one, so for non-listable, so it won't list the comment, okay, when you put the double semicolon, okay, double semicolon. Okay, so these three directives designed to make programs that use macro are more readable. So this is affecting the .lst file, okay, but it does not affect the object of the program file itself, the .exe. So this is just the information for you. So this one is actually when we did the real programming on the MASM software. Okay, then we will see how this macro affects on that. Okay, one more thing that local can also be used, right? Like the inside the macro, okay? So this macro can be expanded more than once, okay? So there is a label in the label field of the body of the macro. So when we define first on top, we define that is a macro, and then below that, within that macro and NM, so we can also put a label. We call that as local. Okay. All right. So what is the usage of this local, right? So meaning that if we want to, we have multiple names to be used, right? So we need to define first, okay, what is inside those macros, okay? If not, the macro won't recognize, okay, what kind of data, okay, what kind of data or what kind of string that you want to use within that macro. Okay, so that's why we must put the label as local. Okay, so the labeling that we make to each of these data must be declared at the local. Okay, so local must be right after the micro directive. Okay, after the macro, and then you put the local. Okay, so the local is used to declare all names and labels at once. Okay, for example over here. Okay, so what we want to do here is we want to make a label back, okay, define, okay, in the local, okay, after the micro directive. Okay, so let's say, so example 4.7, okay, ask you to write a macro that multiplies two words by repeated addition, then save the result. Okay, so here we see that, okay, so what micro do is here to multiply, right, to multiply. Okay, and then we have a local named as back. Okay, as you can see here, macro, we have a directive local as back. Okay, so what does this macro do is to multiply, okay, the value of, so this is the comment, right? So this macro computes result equals to value 1 times value 2. Okay? And then you have the double semicolon as you did before. So this won't be shown. This won't be shown in the .lst file. Okay. So only this will be shown in the .lst file. So with one semicolon. Okay. So it will compute the result of value 1 times value 2, okay, by repeated addition. Okay. So the value 1 and value 2 are the word operands. Okay. Results is a double word. Okay. So okay, let's say we already put the value 1 in the register. Okay. Value 1 we put into the BX, value 2 we put into the BX. CX, okay, and then so subtract AX, so the AX will be 0, okay, and then move AX into the DX, okay, now the DX is also 0. Okay, so now what we need to do is BX is added to AX, okay, so AX now change to the value of BX, which is the value 1, okay, and then okay, so we assign it DX, okay, ADC, okay, ADC DX to 0, okay. So add carry, okay, if there is 1. Okay, if there is 1, then we add carry. Okay, so DX will change according if there is a carry. Okay, and then loop, what we need to do is to loop back. Okay, continue until CX is 0. Okay, so this is what we need to do, right? So mean that when CX we still have a certain value from there, it will keep adding the results again and again. So the result is in terms of multiplication of value 1 and value 2. So when back is called, okay, so mean that this command, it will keep repeating this add and ADC. Okay, so it will keep repeated until CX is 0. Okay, and finally, so the result of the addition, okay, results of the addition will be moved, okay, to the result. Okay, and then save that in terms of word. Okay, so result plus 2. Okay, so that is the function of macro and local inside the macro. Okay, so mean that you don't need to repeatedly type. Okay, you want to multiply this, okay, multiply that value, I mean value 1 and value 2, so you don't need to repeatedly type. Okay, let's say you want to assign bx to 02 cx01, okay, and then next time you want bx become 01 and then cx become 01, so it will not be repeatedly written in the code. So we just use the macro to perform that function. Okay, so that is the function of macro and the local. Okay, there is also another directive, okay, which is include, okay, which is include inside the macro, but this function is not too important, right? So it just allows us to write the macros and save the macros in a file and later bring them into any file. Okay. All right. So that is about the macro. Okay. So we already finished with the chapter 4. So remember that your test 2 will be up to this chapter. Okay. And I will have a couple of assignments for you. So I will upload it, okay, within by tomorrow. Okay, you're gonna have the chapter 2, chapter 3, and chapter 4 assignments. All right, but the assignments will be due in the week 14. Okay, so just do the exercise over there for your preparation of your test 2. Okay. Any other question before we move to the next chapter, which is the chapter 5?
Doctor, can I have a confirmation for the chapter for our test? What chapter?
Chapter 2, chapter 3, and chapter 4. 3 chapters. Okay, it will be 3 chapters, chapter 2, chapter 3, and chapter 4.
Doctor,
Yes?
for local, do we need to repeat it from sub AX?
What is it, the question again?
Local.
Oh, local. Okay, actually local, we just use that inside the macro. Okay, this is just to mention what is, let's say we want to define something. Okay, over here, for example, we use that as a loop. Okay, so meaning that we just type once. Okay, we just type once back, and then this one back we just put here. It's like the normal programming. Okay, but we define it inside the macro. But let's say if we don't define this, okay, if we don't write this, so what happened? Okay, the macro cannot know what is this back command, right? Like the normal one inside that we use the assembly language. Okay, so in order to use, okay, this function, okay, we need to first define it at the top. Okay, so like you declare the variable right over here. So like macro as well, let's say you put the local, let's say you put add. Okay, so whenever you put over here the add, then only you can use this add, okay, to repeat the assignment. Okay, to repeat that. Okay, so this is what is repeated over here. Let's say over here this is we use as back. Okay, so this is what is repeated. Okay, there are more examples. I think if you have the book, all right, if you have the book, then you can, because I don't have a soft copy of this book, but there is, I think there is an older version of the book, which is a fourth version. I think it is available online, okay, where you can find it. Okay, so you can refer. There is examples in the book on the usage of the macro and local. Okay, they will show you another type of example of that. Okay, any other question? But mostly, what we learn is we just use this local, okay, just to do the looping, okay.
Okay.
Yes, any other question?
For the test, what kind of exam will it be? Is it like the last one?
What kind of what?
What kind of questions will come out? Like subjective, objective, what? Is it
Oh,
similar?
all of those will be similar like your test one, okay. It will be subjective, okay, problem solving.
Okay, doctor.
Okay, and then as I mentioned in your test, those actually who I already shared, so last time I already shared you with the assignments on the chapter 0 and chapter 1. So actually, if you did that, you managed to answer that. But however, we will again discuss discuss about test 2 next week, okay, during the Tuesday class. Okay. I think I will stop here for today, right? So I think I will start with the new chapter on next Tuesday, which will be on the keyboard and mouse programming. So we already seen, okay, what we can do with the screen, right? With the interrupt, okay. And next, we are looking into the keyboard and mouse programming, okay. How the keyboard and mouse can work with the CPU, okay. All right, so please turn on your camera for me to take your attendance.
Doctor, what
Yes.
dates for our exam? Can I have
So
confirmation, please?
it will be next Thursday on 17. 17
It's only 1 hour.
is only 1 hour. Yes.
Mm.
But maybe it depends. Maybe I'm gonna give you some extra time to answer the question. But that is actually, as I say, as I seen from your test one, some of you managed to did it well. So I don't think it's a problem with the time. Okay. As long as you got enough practice, then I think you can do well in your exam. Okay. Right. So let me count from 10. 10, 9, 8, 7, 6, 5, 4, 3, 1. Okay. Thank you, everyone. So have a nice day. All right. Assalamualaikum and bye-bye. Okay.
Thank you, Doctor.
Thank you, Doctor. Sama.
Sana dulu.
Thank you, Doctor.
Bye-bye.
Thank you, Doctor.
Doctor.